Imagine a jet that can take off from a tiny aircraft carrier, hover in midair like a helicopter, and then blast past the speed of sound, all while being invisible to radar. Sounds impossible, right? This isn't science fiction. This is the F-35B Lightning II, the most advanced short takeoff and vertical landing jet ever built. But what kind of engineering magic makes a 40,000-pound machine fly, stop, and stand still in the air? And how did Lockheed Martin solve the impossible balance between stealth, speed, and vertical thrust? Stay with us till the end, because what you'll discover about this aircraft will completely change how you see modern aviation. The impossible dream, a jet that could do it all. In the 1990s, the US military faced a nightmare scenario. The Navy, Air Force, and Marine Corps each needed a new fighter jet, but all with very different needs. The Marines wanted a jet that could take off from short runways and land vertically on small carriers. The Air Force needed stealth and speed for deep strike missions. The Navy demanded ruggedness and range for carrier operations. Creating one jet to satisfy all three seemed like a fantasy, until Lockheed Martin stepped in with the concept that would become the F-35 Lightning II. But the F-35B, designed for the Marines, would be the most radical version. The secret to vertical flight, the lift fan system. At the heart of the F-35B's magic lies a piece of technology so bold that it looks straight out of a sci-fi movie, the lift fan system. Developed in collaboration with Rolls-Royce, the lift fan is a giant, vertically mounted turbine placed right behind the cockpit. When the pilot engages in vertical mode, a clutch connects this lift fan to the main engine via a drive shaft spinning at nearly 30,000 horsepower. In an instant, the fan starts pulling cold air from above and pushes it down through twin doors, generating nearly 20,000 pounds of vertical thrust. Simultaneously, the engine nozzle at the back rotates downward to direct exhaust straight down. The engineering nightmare, balancing weight and power. But making a jet hover isn't just about power. It's about perfect balance. Every pound matters. If the F-35B was even slightly heavier in the wrong area, it would tip and crash. Lockheed Martin engineers had to shave off hundreds of kilograms without compromising stealth or durability. The lift fan alone added significant weight, so they redesigned the aircraft's internal layout from scratch. That's enough to lift 30 cars straight off the ground. To this day, the F-35B remains one of the only supersonic aircraft capable of vertical takeoff and landing, a feat that seemed physically impossible just a few decades ago. The swiveling nozzle, a mechanical marvel. If the lift fan is the F-35B's heart, then the swiveling rear nozzle is its muscle. Known as the three-bearing swivel nozzle, this device is an engineering masterpiece. It allows the F-35B's jet exhaust to rotate 95 degrees downward in a split second, smoothly, precisely, and safely. Made from heat-resistant titanium alloys, this nozzle handles exhaust temperatures exceeding 1,600 degrees Celsius. It's connected to the engine through a flexible joint that redirects thrust without disrupting airflow, a concept that took Rolls-Royce engineers years to perfect. The brain behind the jet, advanced flight control systems. Flying the F-35B isn't about raw skill, it's about trusting the machine. When the pilot switches to hover mode, the fly-by-wire control system takes over. Thousands of sensors measure every micro-movement of the jet, adjusting thrust in all directions hundreds of times per second. This digital brain automatically corrects for wind gusts, turbulence, and uneven air pressure. The pilot only needs to control altitude and direction, the system handles everything else. In the early test flights, engineers realized that even the slightest human correction could cause oscillations. So they wrote algorithms that anticipate pilot input, ensuring stability so perfect it feels supernatural. Stealth in motion, the invisible jet. Stealth is what gives the F-35B its deadliest edge. Every inch of the aircraft is designed to scatter and absorb radar waves. Its smooth, angular surfaces prevent radar reflections, while the edges align with radar invisible angles. Even the vertical lift systems, which could easily ruin stealth, were ingeniously designed with flush-fitting doors that close seamlessly when not in use. This combination of stealth and vertical capability was previously thought to be mutually exclusive, yet the engineers managed to fuse them in one extraordinary machine. The powerhouse engine, Pratt & Whitney F-135. At the center of all this insanity lies one of the most powerful jet engines ever built, the Pratt & Whitney F-135. Producing up to 43,000 pounds of thrust, this engine is so advanced that even a slight mistake in assembly could destroy it. Inside, air is compressed 30 times before being mixed with fuel and ignited in a controlled explosion that occurs 2,000 times per second. The F-135 was derived from the engine that powered the F-22 Raptor but had to be completely re-engineered for the F-35B's lift fan system. It had to be compact, reliable, and capable of switching from vertical to horizontal flight instantly. The art of transition from hover to supersonic. Perhaps the most breathtaking maneuver of the F-35B is its transition from hover to flight. In this phase, the jet switches from vertical thrust to forward thrust, a process that takes less than 10 seconds but involves dozens of moving parts and synchronized systems. As the pilot pushes the throttle, the rear nozzle gradually pivots backward, the lift fan clutch disengages, and the aircraft accelerates forward. All of this must happen seamlessly, or the plane risks catastrophic imbalance. The control software automatically adjusts the thrust vectoring, wing lift, and center of gravity as it transitions. The helmet of the future? Pilot integration. The F-35B's engineering brilliance doesn't stop with the airframe. It extends to the pilot's helmet, which might be the most advanced piece of flight gear ever made. Each helmet costs over $400,000 and is custom fitted to the pilot's head. It integrates directly with the jet sensors, displaying a 360-degree real-time feed of the outside world, even through the aircraft's floor. This is made possible by the Distributed Aperture System, DAS, a network of infrared cameras mounted around the jet. When the pilot looks down, they can literally see through the aircraft. No other jet offers this kind of situational awareness. The stealth carrier revolution, why the F-35B exists. The F-35B wasn't just built for show, it was built to revolutionize naval aviation. Before the F-35B, only massive supercarriers with catapults could launch advanced jets. Smaller amphibious assault ships could only carry helicopters and slow Harriers. But with the F-35B, the Marines can now turn small ships into mini-aircraft carriers. A single flat deck can deploy stealth fighters capable of deep strikes, reconnaissance, and close air support. This completely changed global naval strategy. The cost of innovation, billions for perfection. Critics still question the price tag, and they are not wrong to. The F-35 program has cost over $1 trillion when factoring in development and long-term support. But defenders argue that such innovation always comes at a cost. Every rivet, every algorithm, and every stealth coating represents decades of research and billions in experimentation. And when you consider the F-35B replacing multiple aircraft types, the long-term economics become clearer. It's not just one jet, it's an entire ecosystem of technology. The future of vertical flight, what comes next? The F-35B has set a new benchmark for what's possible, but engineers are already thinking ahead. Future generations may integrate hybrid electric systems, AI-assisted controls, and adaptive stealth coatings. Some experts predict a 6th-generation VTOL stealth jet could emerge within decades, capable of operating autonomously. But one thing is certain, every future aircraft will owe a debt to the F-35B. It proved that the impossible could be done, that a stealth jet could take off vertically, fly supersonic, and remain invisible all at once. The F-35B isn't just the product of engineering, it's the definition of it. A jet that redefined physics. The F-35B stands as a monument to human imagination, a machine that rewrote the rules of flight. It hovers, it vanishes from radar, and it fights with intelligence beyond comprehension. In a world where technology defines power, the F-35B isn't just an aircraft, it's a symbol of what happens when dreams meet determination. Next time you see footage of it gently rising from a ship deck, remember, beneath that smooth motion lies a symphony of gears, turbines, and code, all working in perfect harmony to defy gravity itself. If you enjoyed this deep dive into the world of aviation marvels, hit that like button, subscribe, and let me know. Which aircraft should we explore next? Because this was only the beginning of the story of human flight.